Another concept in object-oriented programming is the concept of the abstract class. An abstract class is a class that can be inherited from, but that cannot be instantiated directly. A good example of a class that qualifies to be an abstract class is our shape class. As I've mentioned several times, when you're writing, say, a graphics program, you don't create a shape, you create a type of shape. A circle, a square, a rectangle, or some other type of shape. So having the class shape be something we can instantiate really doesn't make a lot of sense. And in fact, could be a problem if somebody inadvertently created a shape but wasn't able to do anything with it because the shape class may not be completely implemented as far as interface methods that you need for your graphics program. So a way to use shape as a superclass and yet not allow a programmer to instantiate it is by making it abstract. And to make it abstract, all we have to do is add the keyword abstract before the keyword class in the first line of the definition. So instead of public class shape, we now have public abstract class shape. So this means the shape class can be inherited from but cannot be instantiated directly. And let me show you what that means. So we'll save the file. Let's create a new program. Which you already have here, and you see that I've created a shape object. So I've written shape S1 equals new shape 3, 3 for the X and Y coordinates. Now, I've already made shape abstract, so I should not be able to instantiate it. Let's give it a try. If I try to compile the program, you'll see I get an error message. Let me bring this up on the screen a little bit higher so you can see it better. Shape is abstract, cannot be instantiated. So once you've declared a class as abstract, then you cannot instantiate an object of that class, but you can use it to create other classes. So for example, I can do this. Create a circle class. We'll call the draw method just to verify that it works. Save the file. Compile the program. Oops, I forgot to take shape out. Okay, let's comment that out. Save the file. Compile again. So it's clear that we can use shape as a superclass when it's declared abstract, but we cannot instantiate it directly. Another thing we can do is we can make abstract methods. You'll notice I don't have a method for draw here, but I can create an abstract draw method like so. Notice that I do not have a body, I simply have a method named draw. And what this tells someone looking at this class is that a class that inherits from shape should implement a draw method, but not necessarily inherit the body of a shape's draw method. It doesn't make sense to have a draw method for just a shape because we haven't defined the shape. So rather than have a body that does something meaningless like what we had before where we had it print out the X and Y coordinates, that doesn't make any sense at all. It's better to make the method abstract and then implement it in a subclass for a particular type of shape. So to review, an abstract class is a class that can be inherited from, but that cannot be instantiated directly. In this way, someone designing a complex program, such as a graphics program, will have a clear idea of what needs to be in a particular type of shape, such as a circle or a rectangle, and yet they don't have to worry about instantiating the shape class by mistake because it cannot be instantiated since it's abstract. Now we're going to look in the next lesson at another type of class called an interface. And an interface is just a class that has method names only, but no method definitions. And what that means is that when you inherit from an interface, you're saying, my class is going to have these features. And then in that inherited class, you will define exactly how those features work. And we'll look at interfaces in the next lesson.